solve it the same way because it's because of where the variable is. You would still come up with an exponential. So what would that exponential equation be here? 64 to the 2/3 is equal to x, right? And that's x all by itself already. We just have to simplify that, right? We have x alone already. We don't have to do any other steps like we had to in the one before this. All we have to do is be able to simplify 64 to the 2/3. What does that mean? This is the cube root of 64 squared. And it doesn't matter. Does it matter what order you do those things in? Can you find the cube root first and then square it? Or do you have to square 64 first and then find the cube root? Okay. Actually, it typically doesn't matter as long as there's no signs going on in here. It doesn't matter which one you do first. So it'd be easier probably to do the cube root of 64, which would be 4, and then square it is 16. So the answer is 16, what most of you said. So those of you that got 5, 12, and 4, you need to understand why the answer is 16. Okay. Can you plug that into your calculator? Okay. Yeah, you can go 64 caret parentheses 2 divided by 3, and it should come up with 16. So you can plug that into your calculator as long as you know what it means. So you put 64 caret 2/3? Are you sure you didn't do 3/2? Oh, yeah, you do have to do parentheses. Yeah, if you didn't do parentheses, then what would it do? It would do, it would go 64 squared plus 3. Yeah. Yeah, it would square 64 and then add 3 to the answer, which wouldn't have anything to do with what we're doing. So, yeah, you do have to do it in parentheses. That's true. Okay, and I think that is our last slide, is it? Yeah. Okay, so there's a homework if you're doing it out of the book. I think you'll find this one, because they're all, or a lot of them are calculations like what we were just doing. I think you'll find that this goes relatively quickly, at least on Math Excel, that you'll be able to go through this one pretty quickly. Okay. I'm hoping that through this section that we're getting a good kind of base feel for what a logarithm is, because in the next section tomorrow what we're going to be doing is going through just a bunch of calculations with them. And so hopefully what you did with logs in Algebra 2 combined with what we've done for the last few days will give you a good base for that. So, okay. Question? Can somebody turn on the lights, please? About logarithms? Uh-huh. Uh-huh. Okay. I've not heard of that, but could be. Okay. I'm not sure how that would be an example of a logarithm, though. Because typically a logarithm, in terms of an example, is something that grows rapidly. So it may be stable for a long time. Like we're going to look at an example of the world's population tomorrow, that it stayed level for a long time and then just... That's true. Right. Interest, yeah, interest on loans, depending on what kind of loan you have. You can pay very little on the principal to begin with, and then all of a sudden, if you last long enough, then you're paying a lot on the principal. But yeah. I'm not sure what he would be referring to. AE? Yeah, I'm not sure. Yeah, bring it in and we can look at it.